very very important topic in trigonometry. That is trigonometric equations. Trigonometric equations. Trigonometric equations. Trigonometric equations. Already we know that equations means an open sentence containing the sign, an open sentence containing the sign is equals to, an open sentence containing the sign is equals to, is called what? Equations. In the earlier classes also, we solved some equations. F of x is equals to 0, f of x is equals to 0, that is ax plus b is equals to 0, where a is not equals to 0. Some linear equations already we solved them, and some quadratic equations, that is ax square plus bx plus c is equals to 0. Here also where a is not equal to 0, this is clearly quadratic equation already solved in the earlier classes. That means solve means here what is the solution? Solution of this equation means x0 is any real number. X0 is any real number. If you substitute x0 in f of x, if f of x0 is equals to 0, if f of x0 is equals to 0, then x0 is called a solution of the given equation. That means solution is the number which satisfies the given equation. Solution is the number, that is any real number which satisfies the given equation is called the solution of the given equation. Already we solved in earlier classes. But in this section, in this chapter, we discuss some trigonometric functions. That is some trigonometric equations. What is the meaning of trigonometric equations? Means trigonometric equations. Trigonometric equation. What is the definition of the trigonometric equations? Means an equation consisting of trigonometric functions as a variable. An equation consisting of trigonometric functions as a variables, or trigonometric functions of the variables angle theta belongs to R is called trigonometric equations. Trigonometric equations means an equation consisting of trigonometric functions as a variables. Here observe here, these are equations, that is algebraic equation, that is ax plus b is equals to 0, ax square plus bx plus 0. This is a linear equation, this is quadratic equation. Here x is a variable. Observe here, x is a variable. Here x is a variable. This is the linear variable. This is a linear equation. This is quadratic equation. But trigonometric equation means an equation consisting of trigonometric functions as a variable in the place of x, involving the trigonometric functions in the place of variables. Trigonometric functions are involved. That is an equation consisting of trigonometric functions as a variable. Angle theta belongs to R. Then the functions is called trigonometric equations. For example, 4 Sin square x minus 3 sin x minus 1 is equal to 0. This is a trigonometric equation. Observe here. Ax square plus bx plus c involve trigonometric functions as a variable. Trigonometric functions as a variable. So this is called what? Trigonometric equations. Or that is 3 tan square x. 3 tan square x plus 4 tan x. 4 tan x minus 7 is equal to 0. 3 tan square x plus 4 tan x minus 7 is equal to 0. Observe here, in the place of variable, trigonometric functions are involved. In the place of variables, trigonometric functions are involved. So these type of functions or these type of equations are called what? Trigonometric equations. Trigonometric equations means an equation consisting or containing of trigonometric functions as a variable. Trigonometric functions as a variable. That means in the place of variable, the equation containing trigonometric functions like this. 4 sin square x minus 3 sin x minus 1 is equal to 0. This is a trigonometric equation. 3 tan square x plus 4 tan x minus 7 is equal to 0. This is a trigonometric equations. In the place of variable, trigonometric functions are involved. In the place of variable, trigonometric functions are involved. So these type of equations are called trigonometric equations. That is trigonometric equations. Yes, solution means solution. Solution means the values of the variable angle theta. The values of the variable angle theta, that is any number satisfying the given trigonometric equations. Given trigonometric equations is called solution of the trigonometric equation. Is called a solution, right? Observe, solution means the values of the variable angle theta, the values of the variable angle theta, that is any number that satisfying the given trigonometric equation, is called a solution. Solution means theta belongs to any real number. That satisfying the given trigonometric equations. Then theta is called the solution of the given trigonometric equation. Then theta is called what? Solution of the given trigonometric equation. For example, if you take sin theta is equal to 1 by 2. Sin theta is equal to 1 by 2. Sin theta is equal to 1 by 2 means clearly we know that sin 30 value, how much? 1 by 2. Sin 30 is 1 by 2. So the solution of the given trigonometric equation is, if you substitute 30 degrees in place of theta is any real number. That means the values of the variable angle theta. That is any number. That satisfying the given trigonometric equation. Is called the solution of the given trigonometric equation. Observe here, sin theta is equal to 1 by 2. In the place of theta, if you substitute theta is equal to 30 degrees. are 5 by 6 radians. 5 by 6 radians. It satisfies the given trigonometric equation. Sin 30 is equal to 1 by 2. Sin 30 value how much? Already we know that sin 30. So sin theta is equal to, that is sin 30 or sin 5 by 6. Clearly theta is equal to 30 degrees. Theta is equal to how much? 30 degrees. So sin theta is equal to 1 by 2 calculated as sin 30. Sin 30 value clearly 1 by 2. So sin 30 is equal to, theta is equal to 1 by 30. So theta satisfying the given trigonometric equations. That is 5 by 6 or theta satisfying the given trigonometric equations. This theta is equal to 30 or theta is equal to 5 by 6 radians is called the solution of the given trigonometric equation. Is called the solution of the given trigonometric equation. So 30 degrees or 5 by 6 radians is a solution of the given trigonometric equation. Next, solution set means the set of solutions. The set of solutions of the trigonometric functions. The set of solutions of the trigonometric equations. The set of solutions of the trigonometric equations is called solution set of the given trigonometric equation. Is called the solution set. Is called the solution set of the given trigonometric equation. Given trigonometric solution set means the set of solutions of the trigonometric equations. The set of solutions of the trigonometric equations. The set of solutions of the trigonometric equations is called the solution set. Solution set of the given trigonometric equation is called the solution set of the given trigonometric equation. That means, how do we know that? Sin all the trigonometric functions are periodic functions. All the trigonometric functions are periodic functions. That means, after period, that is after 2 pi, the values are again repeated. So, sin all the trigonometric functions have infinite number of solutions. All the trigonometric functions have infinite number of solutions. Clearly, observe here, sin theta is equal to 1 by 2. Theta is equal to 30. That is the solution of one of the solution of the given trigonometric functions. So if you write sin theta equals 1 by 2, sin theta equals example, sin theta is equal to 1 by 2. We want the solution set. Solution set means clearly 5 by 6. 5 by 6 is one of the solution. 5 by 6 is the one of the solution. After 2 pi, the values are repeated. So 13 pi by 6 is also one of the solutions. 13 pi by 6 is also one of the solution. Next, 25 pi by 6 is also one of the solution. 25 pi by 6 is one of the solution. This is sin theta. So it satisfies the given trigonometric equations. 37 pi by 6 is also one of the given solution, and so this solution set, this set is called what? Solution set of the given trigonometric equation. This set is called what? Solution set of the given trigonometric equation. Why means all the trigonometric functions are periodic functions. All the trigonometric functions are periodic functions. That means after the period, that means after 2 pi, sine function is again repeated, same way. So, how many solutions means it has infinite number of solutions. If you write all the solutions in the set, then it is called a solution set. Solution means the values of the variable angle theta, the values of the variable until theta, that is any number, that is any real number satisfying the given trigonometric equation. Satisfying the given trigonometric equation, then the value of theta, is called the solution of the given trigonometric equation. Value of the theta. If you substitute that, sin theta is equal to 1 by 2, clearly this is a trigonometric equation. Sin theta is equal to 1 by 2. This is a trigonometric equation. If you substitute theta is equal to 30, sin 30 value 1 by 2, so theta equals 30 is a solution of the given trigonometric equation. Theta is any number that satisfies the given trigonometric equations. Theta is any real number that satisfies the given trigonometric equations is called the solution of the given trigonometric equation. Solution set means the set of solutions. The set of solutions of the trigonometric equation. The set of solutions of the trigonometric equations is called the solution set of the trigonometric equations. That means all the trigonometric functions are periodic functions. That means it has infinite number of solutions. It has infinite number of solutions. These solutions are written in the one set. This set is called what? Solution set. Next, that is solution. Next, general solution. General solution. General solution means a general solution of the equation is an expression. A general solution. A general solution of the equation. A general solution of the equation. A general solution of the equation is an expression. Is an expression. The general solution of the equation is an expression of the form. A general solution of the equation is nothing but expression. General solution is nothing but an expression of the form theta naught plus, that is f of n. Theta naught plus f of n. Theta naught plus f of n, where theta naught is a particular solution, where theta naught is a particular solution. Theta naught is a particular solution, and f of n is a function, and f of n. Theta naught here, general solution is nothing but is an expression. Here theta naught is a particular solution, and f of n is a function. F of n is a function. F of n is a function of n belongs to z. Function of n is belongs to z. Function of n is belongs to z involving pi. Involving pi is called what? General solution of the equation. Observe here, general solution. Already we discussed solution means theta is any number that satisfies the given trigonometric equations is called what? Solution. But we discuss here general solution. General solution means a general solution of the equation. A general solution of the equation is an expression. General solution of the equation is an expression of the form theta naught plus f of n. Theta naught plus f of n. Clearly, theta naught is a particular solution. Theta naught is a particular solution, and f of n is a function. Theta naught is a particular solution, and f of n is a function of n belongs to z involving pi. Involving pi is called the general solution of the given trigonometric equation. Is called the general solution of the given trigonometric equation. For example, the equation sin theta is equal to 1 by 2 has a solution. For example, For example, the equation sin theta is equal to, already we take sin theta is equal to 1 by 2 as a solution, already we know that sin theta is equal to, the trigonometric equation sin theta is equal to 1 by 2. The trigonometric equation sin theta is equal to 1 by 2 as a solution, that is theta is equal to pi by 6. Theta is equal to how much? Theta is equal to pi by 6. Theta is equal to pi by 6. But theta is equal to theta is equal to 5 pi by 6 also. It will satisfy the given trigonometric equation. Theta is equal to 13 pi by 6. 13 pi by 6 also. It will satisfy the given trigonometric equations. And 25 pi by 6. 25 pi by 6 also. It will satisfy the given trigonometric equations, and so on. Are the solutions of these equations. Are the solutions of given trigonometric are the solutions of the given trigonometric equations. The general solution is a expression. General solution is a expression that is involve theta and f of n. Theta is nothing but particular solution. F of n is nothing but function. F of n is nothing but function of n belongs to z involving pi. So the general solution is clearly here. Therefore, the general solution. Clearly, the general solution is theta is equal to 2n pi. That means 2n pi plus pi by 6. Theta is equal to 2n pi plus pi by 6. 5 by 6 is a particular solution of the given trigonometric equation. 5 by 6 is a particular solution of the given trigonometric equations. 2n pi is the function, and n is belongs to z involving pi. Any trigonometric equation, sine function has two particular solutions. That is pi by 6 or 5 pi by 6 also. So theta is equal to 2n pi, plus 5 pi by 6. 2n pi plus 5 pi by 6. 2n pi plus 5 pi by 6. Where theta n is belongs to z. If theta is a solution of a trigonometric equation, then 2n pi plus theta is also a solution of the same equation. Observe here, general solution means a general solution of the equation. General solution of the equation is an expression. It is in the form of theta naught plus f of n. Theta naught is a particular solution. F of n is a function. That is n belongs to z and involving pi. Is called the general solution of the given trigonometric equation. If you consider the trigonometric equation, that is sin theta is equal to 1 by 2. What is the particular solution of the given trigonometric equation? Is theta is equal to pi by 6. Theta is equal to pi by 6 is a particular solution of the trigonometric equation, or theta is equal to 5 pi by 6 also a particular solution of the given trigonometric equation. So pi by 6, 5 pi by 6, and 13 pi by 6, and 25 by 6, and so on. Are the solutions of the given trigonometric equations. Therefore, the general solution are the solutions. So by using pi by 6 and 13 pi by 6, 25 by 6, and 5 pi by 6, how to write the general solution is, observe here, 2n pi. F of n is a function involving n and pi is n is belongs to z and involving pi. That is, f of n is a function and theta naught is a particular solution. So theta is equal to 2n pi plus pi by 6. If you substitute 0 0 plus pi by 6, here we get pi by 6. If you substitute n equals to 1, 2 ones are 2, 2 into pi, 2 pi, 6 2s are 12, 1 plus pi is clearly 13 pi by 6. If you take n value 2, 2 2s are 4, 6 4s 24, 24 plus 1, that is 25 by 6 is the one of this one. And so on. If data is equal to 2n pi plus 5 pi by 6, 2n pi plus 5 pi by 6 is also a general solution. 2n pi plus 5 by 6 is also general solution, and 2n pi plus 5 pi by 6 is also a given trigonometric general solution of the given trigonometric equations. So observe here, if theta is a solution of trigonometric equation, then 2n pi plus theta is a solution of that given trigonometric equation. Theta is a solution of trigonometric equation. Theta is a solution of trigonometric equation. Then 2n pi plus theta. Then 2n pi plus theta. 2n pi plus theta. Where n is belongs to z. Where n is belongs to z is also a solution of the same equation. Is also a solution of the same equation. Is also a solution of the same equation. Since 2 pi is the period of all the trigonometric functions. Why? Because 2 pi is the period of all the trigonometric functions. 2 pi is the period of all the trigonometric functions. So 2n pi plus general solution is compulsory in the form of 2n pi plus theta. 2 pi is a period of all trigonometric functions. Let us discuss what is the principal solution and what is the principal solution and general solution. Again, yes, we discuss principal solution and how to find the general solution also. Principal solution means principal solution. Principal solution means if the equation involves a variable theta, that is clearly 0 is less than or equals to theta is less than 2 pi. 0 is less than or equals to theta is less than 2 pi. Then the solutions are called. Principal solutions. Then the solutions are called principal solutions. Principal solution means any trigonometric functions has infinite number of solutions. Why? Because its period is 2 pi. So after the periodic function, all the trigonometric functions are periodic functions. So after the period, the values are repeated. So every trigonometric function has infinite number of solutions. But principal solution means the value of theta, which is lying between 0 and 2 pi. That is 0 is less than or equals to theta is less than 2 pi. 0 is less than or equals to theta is less than 2 pi. 0 is less than or equals to theta is less than 2 pi. Then the angle theta is called the principal solution of the given trigonometric function. Is called the principal solution. Observe here, principal solution means if the equation involves a variable, that is theta is always lies between 0 is less than or equals to theta is less than 2 pi. 0 is less than or equals to theta is less than 2 pi. Then the theta is called the principal solutions of the given trigonometric functions. Principal solutions of the given trigonometric functions. Already we know that the sin theta is equals to how much? 1 by 2. Theta is equals to pi by 6. Solutions are pi by 6, that is 5 pi by 6 and 13 pi by 6 and 25 by 6 and so on and so on. But here pi by 6 means pi by 6 clearly it is lies between 0 and 2 pi. Pi by 6 it is lies between 0 and 2 pi. 5 pi by 6 means 5 pi by 6 means 6 1 6 30 35 is 150. So it is also 5 pi by 6 also lies between 0 and 2 pi. So 13 pi by 6 not at all lies between 0 and 2 pi. And 25 pi by 6 also not lie between 0 and 2 pi. So here pi by 6 comma 5 pi by 6 are 5 by 6 comma 5 pi by 6 are principal solutions. Principal solutions of the given trigonometric equation. Observe here. If you take one example, sin theta is equals to 1 by 2. Sin theta equals to 1 by 2. That means it has infinite number of solutions. Already we know that general solution means 2n pi plus pi by 6. What is the general solution here? That is clearly theta is equals to how much? 2n pi plus pi by 6. 2n pi plus pi by 6. If you substitute 0, that is pi by 6. If you substitute 1, 6 2 is 12 plus 1, that is 13 pi by 6 also solution. If you substitute 2, 2 2 is 4, 6 4 is 24, 24 plus 1, 25 by 6 also solution. If you substitute 3, 2 3 is 6, 6 6, 36 plus 1, 37 pi by 6 also solution and so on. It has clearly infinite number of solutions. Infinite number of solutions. In these solutions, among these solutions, the solutions if lie between 0 and 2 pi, 0 is less than or equals to theta is less than 2 pi. Why? Because 2 pi is the period of the other trigonometric functions. So 0 is less than or equals to theta is less than 2 pi. Then the theta is called the principal solution of the given trigonometric equation. Principal solution or particular solution. Principal solution of the given trigonometric equation. So here sin theta equals 1 by 2. Clearly theta is equals 5 by 6. 5 by 6. So here pi by 6 is lies between 0 and 2 pi. Pi by 6 is lies between 0 and 2 pi. So clearly pi by 6 is a solution, principal solution of the given trigonometric equation. 5 pi by 6 also lies between 0 and 2 pi. That means 5 pi by 6 is how much? 150 degrees. So here 0 to 360 degrees. 0 to 360 degrees. So 5 pi by 6 also lies between 0 and 2 pi. Clearly it is also a principal solution of the given trigonometric equation. But 13 pi by 6 not a principal solution of the given trigonometric equation. 25 by 6 is not a principal solution of the given trigonometric equations. Already we discussed. General solution is a in which one of the expression it is contained theta naught plus f of n. That is involves integer n and multiple of pi. That is called what? General solution. Already discussed that is general solution. This is what? Principal solution. Observe here, principal solution means the equation involves variable which a variable involves that is always lies between 0 and 2 pi. 0 is less than 2 pi. Then the value of theta is called the principal solution of the given trigonometric equations. Principal solution of the given trigonometric equation. In this example, pi by 6 and 5 pi by 6 are principal solutions. Why? Because pi by 6 lie between 0 and 2 pi. And 5 pi by 6 also lie between 0 and 2 pi. 0 and 2 pi is only about 360 degrees. Pi by 6 means 180 by 6 clearly 30 degrees. 30 degrees lie between 0 and 2 pi. And 5 pi by 6 also 150 degrees. 150 degrees also lie between 0 and 2 pi. So pi by 6 and 5 pi by 6 are the principal solutions of the given trigonometric equations. But 13 pi by 6 25/6, 25/6, and so on. Not a principal solution of the given trigonometric equations. Yes, that is the principal solution, general solution of the trigonometric equations. In trigonometric equations, how to find the principal solution? Means some definitions is there. First one, the trigonometric equation. First one, already we know that the function f of x is equals to sin x. The function f of x is equals to the function f of x is equals to sin x. The function f of x is equals to sin x. What is the range and what is the range and what is the domain means? f of x is equals to sin x has domain is here r, and a range is clearly -1 to +1. Has domain is r and real numbers, and its range is closed interval -1 to +1. Closed interval -1 to +1 means the values of the function which is right between -1 and +1 and including -1 and +1. That is called the range. So the function f of x is equals to sin x. The function f of x equals sin x has a domain is r and the range is -1 to +1. If we define the function, if we define the function, that is f max -π/2 to +π/2 -1 to +1. F max -π/2 to -π/2 +π/2 -1 to +1 by f of x is equals to sin x by f of x is equals to sin x by f of x is equals to sin x. Then f is said to be f is a hero. Bijection is f is here. Bijection means the function which is 1 and onto, then the function is called bijection. So clearly sin x is a bijection if function is mapping from -π/2 to π/2 to -1 to -1 to +1, then sin f of x is a bijection function. Bijective function means the function will satisfy the 1 and onto functions. Bijective function. Hence for each k belongs to -1 to +1. Hence for each k belongs to -1 to +1, for each k belongs to -1 to +1, there exists unique value. There exists unique value of theta. There exists unique value. Theta is belongs to -π/2. Unique value. Theta is belongs to -π/2 to +π/2. -π/2 +π/2. Such that sin theta is equals to k. Such that sin theta is equals to k. Such that sin theta is equals to k. This theta belongs to -π/2 to +π/2. This theta belongs to -π/2 to +π/2. This theta belongs to -π/2 +π/2 is called the principal solution of the given equation. Is called the given equation. is called the principal solution of the given equations. Observe here. Already we discussed in previous, that is what is the principal solution and what is the general solution. Principal solution means the value of theta, the value of the solution theta, which is lies between 0 is less than or equals to theta is less than 2 pi, then the theta is called the principal solution of the given trigonometric equation. General solution means general solution is a solution of the form as an expression. General solution is an expression which is expressed with the theta naught plus f of n. Theta naught plus f of n. Theta naught here clearly theta naught is a that is principal solution and f of n is a function. F of n is a function. N is belongs to integers and involved pi, that is what general solution. So in trigonometric equations, that is sine, cos, tan, and secant and cosecant, how to adjust the that is principal solution is. For example, observe here, the function f of x is equal to sin x. Already we know that. The function f of x is equal to sin x. The domain of the sin x is clearly R. That means all the real numbers. What is the range? Range is clearly -1 to +1. Closed interval -1 to +1. If we define the function, that is f max -pi/2 to -pi/2 comma pi/2 to -1 to -1 +1, that is closed interval -1 +1 by function f of x is equal to sin x, then f is, when we define the function like this, f max -pi/2 comma pi/2 to -1 +1, then the function that is sin x is then only the sin x is bisective function, that is bisective function. Bisective function means it satisfies one function and onto function also. So f of x is a, when we say that f of x is a bisective function means it is satisfied, it is mapping from f max -pi/2 comma +pi/2 closed interval to -1 comma +1, that is closed interval. Then only we said that f of x is a bisective function. F of x is a bisective function. Then if you take k belongs to in this range, any number, if you take any real number, that is k belongs to -1 to +1. K belongs to -1 to k belongs to closed interval -1 to +1. There exists unique value of the theta. There exists f of x equals sin x. This is the range. If you take any real number, that is which is lies between -1 to +1, that is k belongs to -1 to +1, -1 to +1. There exists unique value. That means single value of theta. That is theta is belongs to -pi/2 to +pi/2, -pi/2 comma +pi/2. In this situation, the theta is called. That means the theta belongs to -pi/2 +pi/2 closed interval. Then theta is called what? Principal solution of the given trigonometric equation. Then theta is called the principal solution of the given trigonometric equations. So, what is the sin x? Sin x is the principal solution. F of x equals sin x, the principal solution is always lies between -pi/2 to +pi/2. -pi/2 to +pi/2, that is closed interval. Theta belongs to -pi/2 to +pi/2. If the equation sin x equals to k, if the equation that is sin function, if the equation sin x equals to k has sin x equals to k, if k belongs to real number, if sin x equals to k, if k belongs to all the real numbers except closed interval -1 to +1, k belongs to all the real numbers. K belongs to all the real numbers except -1 to +1. Except -1 to +1. Then the equation sin x equals to k has no solution. Observe here this point. If the equation sin x equals to k, if you take the trigonometric equation, that is sin x equals to k. The k is, if you take k value, any real number except -1 to +1, closed interval -1 to +1. If you take k is any real number, k is a In this situation, sin x has no solutions. Sin x has no solution. That means, observe here, for example, sin theta is equals to minus 1 by 2. Sin theta is equals to how much? If sin theta is equals to minus 1 by 2. If sin theta is equals to minus 1 by 2 means principal solution is how much? The principal solution here, the principal solution. Clearly, the principal solution is equals to minus 5 by 6. Sin x, if you take sin x is equal, sin theta is equal to minus 1 by 2. Sin theta is equal to minus 1 by 2. Here, in this situation, the principal solution is minus 5 by 6. If you take sin theta is equal to square root of 3 by 2. Sin theta is equal to square root of 3 by 2. What is the principal solution means? What is the principal solution means? Sin theta is equal to square root of 3 by 2. The principal solution is clearly here. Here what? Theta is equal to pi by 3. So, principal solution is equal to clearly pi. Principal solution is equal to pi. That means, if the function that is k belongs to minus 1 to plus 1, observe clearly minus 1 by 2. So, k is lies between minus 1 and plus 1. Lies between minus 1 and plus 1. Observe here, sin theta is equal to k. Sin theta is equal to k means clearly k is lies between closed interval minus 1 to plus 1. So in this situation we have a principal solution, that is the principal solution is clearly minus 5 by 6. Minus 5 by 6 means minus sin of minus 5 by 6 clearly minus sin 30. Sin 30 value how much? Minus 1. That is here also sin theta is equal to square root of 3 by 2. Sin theta is equal to square root of 3 by 2 means already we know that root 3 value 1.732 by 2 means we get 0 point something. Clearly 0 point something also lies between minus 1 and plus 1. Minus 1 and plus 1. In this situation also we have a principal solution, that is pi by 3. That is pi by 3. If you take sin theta is equal to, for example, square root of 2. That is, if you take sin theta is equal to square root of 2. If you take sin theta is equal to square root of 2, we know that square root of 2 value, how much? 1.414. Clearly theta does not belong to minus 1 to plus 1. Does not lies of minus 1 to plus 1. Clearly root 2 value 1.414. So k does not belong to closed interval minus 1 to plus 1. In this situation, sin theta is equal to square root of 2 means in this situation, in this trigonometric function sin theta has no principal solution, no solution. Has no solution. Observe here. When the trigonometric functions exist principal solutions and solutions means already we know that if you take any function, a trigonometric function, that is f of x equals sin x. If you take f of x equals sin x, already we know that domain is real numbers and range is closed interval minus 1 to plus 1. If we define the function that is f max closed interval minus pi by 2 plus pi by 2 to closed interval minus 1 to plus 1. In this situation, sin x is bisective function. That is bijection function. Bijection function means sin x is satisfying 1 and onto functions also. 1 function onto functions. So in this situation, if you take k is any real number which is belongs to closed interval minus 1 to plus 1. There exists unique value theta which is belongs to minus pi by 2, plus pi by 2, that is closed interval minus pi by 2 plus pi by 2. So for every k belongs to minus 1 to plus 1, for every k belongs to minus 1 to closed interval minus 1 to plus 1, there exists unique value minus theta is belongs to minus pi by 2, closed interval minus pi by 2, plus pi by 2. Then in this situation theta is what? In this situation unique value of theta. If this theta belongs to minus pi by 2 closed interval minus pi by 2 plus pi by 2. In this situation, theta is called the principal solution of the given trigonometric equation. Given trigonometric equation is f of x equals to 7x. Otherwise, if theta, if solutions are, for example, if the equation sin x equals to k, sin x is equals to k. If k is belongs to R, k is any real number except closed interval minus 1 to plus 1. If k is any real number except closed interval minus 1 to plus 1, in this situation, sin x has no solution. That means k is any real number except closed interval minus 1 to plus 1. If you give in this case, the given trigonometric equation has no solution. Observe here, if sin theta equals minus 1 by 2, minus 1 by 2 clearly lies between minus 1 and plus 1, closed interval minus 1 and plus 1. Minus 1 by 2 is 0, minus 0.5. Minus 0.5 is clearly lies between this one. So it has a principal solution. It has a solution. What is the principal solution? It's clearly theta is equals to minus 5 by 6 is the principal solution. Take another example. Sin theta is equals to square root of 3 by 2. Sin theta is equals to square root of 3 by 2 means root 3 by 2. Root 3 by 2 already we know that 1.732. 1.732 by 2 means we get 0 point something. Clearly lies between minus 212 minus 1 and plus 1. So in this situation also, sin theta has a solution. That is principal solution. That is pi by 3. If you take one more example, sin theta is equals to square root of 2. Sin theta is equals to square root of 2. Square root of 2 value already we know that 1.414. That is not lie between minus 1 and plus 1. Minus 1 and plus 1. Not at all lie between minus 1 and plus 1. So in this situation, sin function has no solution. In this situation, sin function has no solution. So sin theta equals square root of root 2 has no solution. No solution at all. This is. So also we discussed what is cos and tan, secant and cosecant and cot also. That is yes. Second one, take cosine function. That is cosine function. Cosine function is also bisection function. Cosine function is also B. Cosine function is bisection. Cosine function is also bisection function from interval. Closed interval 0 to 1. Closed interval 0 to pi. Closed interval 0 to pi. Closed interval 0 to pi. On to minus from on to closed interval minus 1 to plus 1. Observe here, take cosine function. What cosine function that is? The cosine function is a bisection when means from 0 to pi. 0 to pi, closed interval 0 to pi. Sine function is bisection when closed interval minus pi by 2 to come up plus pi by 2 to closed interval minus 1 to plus 1. The sine function is a bisection function. So cos function is a bisection function from 0 to pi to on to that is minus 1 to plus 1. Closed interval minus 1 to plus 1. Hence for every k belongs hence for k belongs to minus 1 to plus 1. For every value of k belongs to closed interval minus 1. For every k belongs to closed interval minus 1 to plus 1. There exists unique alpha belongs to 0 to pi. Closed interval. There exists unique alpha is belongs to 0 closed interval 0 to pi such that cos alpha is equal to k such that cos alpha is equal to how much? Cos alpha is equal to k. Cos alpha equals to k. This alpha is called the principal solution of the equation. This alpha is called the principal solution of the equation This alpha is called the principal solution of the equation cos x is equals to k. Observe here. When we say that cos function is bisection function means the cos function is defined from 0 to pi, closed interval 0 to pi, to closed interval -1 to +1, then only we say that cosine function is a bisection function. For every k belongs to closed interval -1 to +1, for every k belongs to, for any real number which is k belongs to closed interval -1 to +1, there exists unique value alpha which is belongs to 0 to pi, such that cos alpha is equals to k, In this situation alpha is called the principal solution. Alpha is called the principal solution of the given trigonometric equation cos x is equals to k. Given trigonometric equation cos x is equals to k. Next, the tangent function is a bisection. Next, see. The tangent function is a bisection. The tangent function is also a bisection, which is mapping from -1 pi by 2 to +pi by 2. From -pi by 2 to +pi by 2. -pi by 2, -pi by 2. Open interval, not closed interval. -pi by 2 to +pi by 2. -pi by 2, +pi by 2 onto R. For example, onto R. That is, F is mapping from open interval -pi by 2, +pi by 2 to R. That is, domain is -pi by 2, +pi by 2. Range is any real number. So that for any k is belongs to R. So that for any k is belongs to R. So that for any k is belongs to R. There exists unique value. There exists unique value, that is alpha, which is belongs to -pi by 2 and +pi by 2. Open interval -pi by 2 to +pi by 2. There exists unique value alpha, which is belongs to open interval -pi by 2 and +pi by 2, such that tan alpha is equals to k. Such that tan alpha is equals to k. Is the then in this situation alpha is called the principal solution of the equation tan x is equals to k. Observe here, when we say that tan function is bisection function, means the tan function is defined from open interval -pi by 2, +pi by 2 to real numbers. Then only we say that tan function is a bisecting function. For every k belongs to R, any k belongs to R, there exists unique value. That is, alpha belongs to -pi by 2 to +pi by 2 open interval. Alpha belongs to -pi by 2 +pi by 2 open interval. Then this alpha is called the principal solution. Of the dividing equation that is tan x equals to k. Next, if k is not equals to 0, Next, if k is not equals to 0, then cot x is equals to k. If k is not equals to 0, cot x is equals to k. if k is not equals to 0, if k is not equals to 0, cot x equals to k, cot x equals to k, if and only if and only if and only if and only tan x is equals to 1 by k, tan x is equals to 1 by k, if and only if tan x is equals to 1 by k, and in this case and in this case tan x is equals to 1 by x, tan x is equals to 1 by k, tan x is equals to 1 by k has, in this case tan x is equals to 1 by k has a solution, in this case tan x is equals to 1 by k has a solution, therefore as a solution, therefore observe here, k is not equals to 0, clearly k value not equals to 0, k value not equals to 0, cot x is equals to k, take cot function, cosine function, that is cotangent function, if and only if tan x is equals to 1 by k, that means 1 by tan is equals to k, tan x is equals to how much? 1 by k, and in this case tan x is equals to 1 by k has solution, tan x is equals to 1 by k has solution, therefore when k is not equals to 0, these two equations have same solution as a solution, therefore when k is not equals to 0, when k is not equals to 0, these two equations that is cos x is equals to k and tan x is equals to 1 by k, these two equations, that is cot x is equals to k, tan x is equals to 1 by k. In this situation, cot x is equals to k and tan x is equals to 1 by k. Cot x equals to k and tan x equals to 1 by k have same solutions. Have same solutions. Have same solution. In this situation, cot x equals to k and tan x is equals to 1 by k have same solutions. If that is, but the principal solution of the equation cot x is a unique real number. But the principal solution of the cot x is the unique real number, that is alpha is belongs to 0 to pi, such that cot alpha is equals to k. But same solution. But what is that? But the principal solution of the cot x equals to k. The principal solution. The principal solution of cot x equals to k is the unique value. Cot x equals to k is the unique value. The principal solution of the cot x equals to k is the unique value. That is unique real number. Alpha belongs to open interval 0 to pi. Alpha belongs to open interval 0 to pi, such that cot alpha is equals to k. What is the meaning of this one means? If k is clearly not equals to 0, cot x is equals to k. If and only if tan x is equals to how much? Tan x is equals to 1 by k. In this situation, and in this case, tan x equals to 1 by k has a solution. Tan x is equals to 1 by k. Tan x equals to 1 by k has a solution. Therefore, when k is not equals to 0. When k is not equals to 0, then tan x has a solution. Tan x has a solution when k is not equals to 0. So these two equations, that means these two equations is nothing but cot x and tan x equals to 1 by k. Cot x equals to k and tan x equals to 1 by k have same solutions. Cot x is equals to k and tan x is equals to 1 by k. Both are have same solutions. But cot x equals to k, cot x equals to k. The principal solution of the cot x equals to k, which is right between alpha, that is the principal solution of the cot x equals to k, the unique value alpha, which is belongs to open interval 0 to 5. Here alpha is belongs to open interval minus pi by 2 comma plus pi by 2 the tan function. But cot function, alpha is belongs to open interval 0 to pi. This alpha is called the principal solution of the given cotangent function, that is cot function. That is secant x is equals to k. Next one. Secant x is equals to k. Next one. Secant x is equals to k if and only if cos x is equals to 1 by k. If cos x is equals to 1 by k. We want the principal solution of the secant x means if secant x is equals to k, then cos x compulsory. Cos x if and only if cos x is equals to 1 by k. The second equation has the second equation has how much? Cos x is equals to 1 by k. The second equation has a solution if and only if has a solution if and only has a solution if and only if has a solution if and only if secant x is equals to k. That means cos x is equals to how much? Cos is the reciprocal of secant function. So cos x is equals to how much? 1 by k. Cos x is equals to how much? 1 by k. So cos x is equals to 1 by k as a solution. Cos x is equals to 1 by k as a solution. Cos x is equals to 1 by k as a solution if and only if modulus of k is equals to 1. Modulus of k is equals to 1. That is modulus of k is always modulus of means absolute value of the k is equals to 1. Then only cos x is equals to 1 by k has a solution. Modulus of k is equals to 1, then cos x is equals to 1 by k has a solution. But in this case the solution set the solution set of cos x is equals to 1 by k. In this case, the solution set of cos x is equals to 1 by k. In this case, the solution set of cos x is equals to 1 by k and secant x is equals to k has maybe same solutions. In this case, the solution set of secant x is equals to k and cos x is equals to 1 by k. Maybe in this situation, in this case, the secant x is equals to k and the secant x is equals to k and cos x is equals to 1 by k. Secant x is equals to k and cos x is equals to 1 by k is the same as the solution of same solutions. Maybe have same solutions. Observe here this one. Secant x is equals to k. If cos x is equals to how much? 1 by k. Cos x is equals to 1 by k. The second equation cos x is equals to 1 by k has solution if and only if mod k value modulus of k, that is absolute value of k is equals to compulsory 1. Observe here, in this case the solution set of secant x is equals to k is same as the solution set of cos x is equals to k. That cos x is equals to 1 by k. That means secant x is equals to k and cos x is equals to 1 by k have the same solution. But the principal solution of cos x is equals to 1 by k may be the principal solution of the cos x is equals to 1 by k may be same as to be the principal solution of the secant x. Therefore, solutions. So the principal solution of cos x is equals to 1 by k same as the principal solution of secant x is equals to k. Secant x is equals to k same as the principal solution of cos x is equals to next. Observe here. Secant x is equals to k. When the principal solution exists means secant x is equals to k means cos x is equals to clearly 1 by k. Why? Because the reciprocal of secant function is cos function. So cos x is equals to 1 by k clearly has a solution if and only if mod k value compulsory, that is absolute value of k is not equals to absolute value of k is equals to 1. In this situation, cos x is equals to 1 by k and secant x is equals to k has same solutions. Cos x is equals to 1 by k and secant x is equals to same solutions. So the principal solution of the secant x is equals to k is the principal solution of the cos x is equals to 1 by k. The principal solution of the secant x is equals to k is the principal solution of the cos x is equals to 1 by k. If you want the principal solution of secant x means the principal solution of the cos x is equals to 1 by k, same, both are same. Next one, if cosecant x is equals to k, cosecant x is equals to k if and only cosecant x is equals to k if and only if sin x is equals to 1 by k. If and only if sin x is equals to 1 by k. Sin x is equals to 1 by k. The second equation has solutions. The second equation has the second equation. That means second equation is here. Sin x is equals to 1 by k. Sin x is equals to 1 by k has the second equation has a solution if and only if the absolute value of modulus of k, that is absolute value of k is clearly greater than or equals to 1. Absolute value of k is greater than or equals to 1. The solution set of secant x is equals to k and the same as the solution set of cosecant x is equals to k may be same as solution set of sin x is equals to 1 by k. The solution set of cosecant x is equals to k same as the solution set of sin x is equals to 1 by 2. That means the principal solution may be referred as the principal solution of the cosecant x is equals to k may be referred as the principal solution of that means that is the principal solution of sin x is equals to 1 by k may be referred as so the principal solution The principal solution of sin x is equals to 1 by k. The principal solution of sin x equals 1 by k may be referred as the principal solution of cosecant x. Cosecant x is equals to k. Observe here, secant and cosecant. If you want the secant x is equals to k, the principal solution means secant x equals to k if and only if cos x is equals to 1 by k. Cos x equals to 1 by k. Cos x equals to 1 by k has a solution. Cos x equals to 1 by k has a solution if and only if modulus of k is equals, that is absolute value of k. Modulus of k or absolute value of k is equals to, modulus of k is or absolute value of k, this is greater than or equals to, modulus of k or absolute value of k is greater than or equals to 1. In this case, secant x is equals to k and cos x is equals to 1 by k have same solutions. So the principal solution of cos x is equals to 1 by k may be referred as the principal solution of the secant x is equals to k. The principal solution of the cos x is equals to 1 by k may be referred as secant x is equals to k. Same this also. If cosecant x is equals to k, if and only if cosecant x is equals to k, if and only if sin x is equals to 1 by k. If and only if sin x is equals to 1 by k. The second equation that means sin x is equals to 1 by k has a solution if and only if modulus of k, that means absolute value of k nearly greater than or equals to 1. The solution set of the solutions in this case, in this situation, the solution set of the cosecant x equals to k and sin x is equals to 1 by k have same solutions. So that's why the principal solution of sin x is equals to 1 by k. The principal solution of sin x is equals to 1 by k may be referred as the principal solution of the cosecant x is equals to k. Cosecant x